Hello. So today I'm going to start solving exercise 2.2 of polynomial chapter, that is for class 9. Now let us see the first thing. So find the value of the polynomial 5x minus 4x square plus 3 at x is equal to 0, x is equal to minus 1 and x is equal to 2. Okay. So when you want to find the value of this polynomial at x is equal to 0, so you will have to substitute the value of x as 0 in this and find what will be the number. So let us see. Let us see the solution. This is the polynomial. P of x is given as 5x square is the polynomial in x. The value of the polynomial P of x at x is equal to 0 is given by P of 0. That means in place of x, I am putting 0. So if we do that, so at x is equal to 0, what it will be? See here, P of 0 will be 5 into 0 minus 4 into 0 raised to 2 plus 3. 5 into 0 is 0 and 0 raised to 2 is 0, 0 into 4 is again 0. So 0 minus 0 plus 3 is 3. So value of the polynomial at x is equal to 0 is 3. So the value of the polynomial p of x, that is 5x minus 4x square plus 3 at x is equal to 0 is 3. X is equal to minus 1. At x is equal to minus 1, we have to calculate p of minus 1. So 5 into minus 1 minus 4 into minus 1 raised to 2 plus 3. So plus into minus is minus, 5 ones are 5. So it is minus 5. Minus 1 square is minus 1 into minus 1 is 1. 1 into minus 4 is 4, minus 4. And this is 3. So minus 5 minus 4 plus 3. So minus 5 minus 4 is minus 9 and plus 3. So minus 9 plus 3 is minus 6. So the value of the polynomial p of x at 5x minus 4x square plus 3 at x is equal to minus 1 is 6. Now let us do at x is equal to 2. So that is we are going to calculate p of 2. P of 2 will be 5 into 2 minus 4 into 2 raised to 2 plus 3. 5 into 2 is 10 minus 4 into 2 square, 2 2s are 4 plus 3. So this is 10, 4 4s are 16. So 10 minus 16 plus 3. So it is 10 plus 3 is 13 minus 16. 13 minus 16 is minus 3. Therefore, the value of the polynomial p of x, that is 5x minus 4x square plus 3 at x is equal to 2 is minus 3. This is clear. So, value of the polynomial is nothing but substituting the value of x to get a numerical value of that polynomial. Now, let's go to the next question. See this question, p of 0, p of 1, p of 2. So, p of 0, that means he wants to calculate the value of the polynomial at 0. We have to calculate the value of the polynomial at 1 and also the value of the polynomial at 2 for each of these polynomials. So let us take the first one. So let us start the solution. Let's take the first polynomial. Now he wants you to calculate p of 0. P of 0 is 0 raised to 2 minus 0 plus 1. 0, 0 plus 1. So what it is? 0 minus 0 plus 1 is 1. That means P of 1 is, P of 0 is 1. Now P of 1, 1 square minus 1 plus 1. What will be? 1 minus 1 plus 1 is 1. So P of 1 is 1. Now calculate P of 2. P of 2 is 2 square minus 2 plus 1. 2 square is 4. 4 minus 2 plus 1. So 4 plus 1 is 5. 5 minus 2 is 3. So P of 2 is 3. Now let us take the second polynomial. Pt, that is 2 plus t 2t square minus t raised to 3. So it is a polynomial in t. So when we are going to substitute 0 So P of 0 will be 2P plus 2t square minus t raised to 3. So wherever t is there, put 0. 2, 0, 2, 0 raised to 2 minus 0 raised to 3. 0 raised to 2 is 0 only. 0 raised to 3 is also 0. And when your 0 is multiplied with 2, it is also will become 0. What will be here? 2 minus plus 0 plus 2 into 0 minus 0. So this all is 0. So the answer is 2. So P of 0 for this polynomial is 2. Now let's calculate P of 1. Wherever 2 plus 1 plus 2 into 1 raised to 2 plus 1 raised to 3. 1 raised to 2 is 1 only. 1 raised to 3 is also 1. So it is 2 plus 1 plus 2 into 1 minus 1. The answer will be 2 plus 1 plus 2 minus 1. 2 2 are 2 plus 1, 3, 3, 4, 5. 5 minus 1 is 4. So P of 1 is 4. Now calculate P of 2. So here we again put the value 2, 2, 2 into 2 raised to 2 minus 2 raised to 3. It will be 2 is this is 2. 2 square is 4 and 2 cube is 8. So let us see this. What has happened? 2, 2, 2 plus 4s are 8 minus 8. Plus 4 plus 8 minus 8 cancels. 2 plus 2 is 4. So P of 2 is 4. Is the third polynomial. P of x is x raised to 3 is given. So when you put x is equal to 0, 0 raised to 3 is 0. Let's take 1. 1 raised to 3 is 1. Let's take 2. 2 raised to 3 is 2 to the 4, 4 to the 8. 8. So P of 2 is 8. Fourth polynomial. P of x is x minus 1, x plus 1. So now we are going to calculate P of 0. So wherever x is there, put 0. 0 minus 1, 0 plus 1. 0 minus 1 is minus 1. 0 plus 1 is 1. Minus 1 into plus 1. Plus 1 ones are 1. Plus minus is minus. Minus 1. P of 1. 1 minus 1. 1 plus 1. 1 minus 1 is 0. 1 plus 1 is 2. So 2 zeros are 0. So P of 1 is 0. P of 2. 2 minus 1, 2 plus 1. 2 minus 1 is 1 and 2 plus 1 is 3. 3 ones are 3. So P of 2 is 3. So that's how we have calculated the 3 values. Now let's go to the next question. Verify whether the following are the zeros of the polynomial indicated against it. Now what is it? See, if the value of the polynomial is 0 for a given value of a variable, then that value of the variable is called the 0 of the polynomial. That means if you are getting P of x as 0, that means the value which you are substituted in place of x is the 0 of the polynomial. That is the solution set, you can say. Once again, I read it. If the value of the polynomial is 0 for a given value of the variable, hence the value which we are substituting, then that value of the variable is called the 0 of the polynomial. Well, let us see. Take the example and see. Our first is this. That means P of x is 3x plus 1 and x value is given as minus 1 by 3. Let's put in this and see whether we are going to, what will be the answer. So we put x is equal to minus 1 by 3 in Px. That is, if P of minus 1 upon 3 is 0, then P x is equal to minus 1 upon 3 is the 0 of P of x. Let us see first. P of minus 1 by 3 I are calculating. So 3 into minus 1 by 3 plus 1. 3, 3 cancels. Minus 1 plus 1 is equal to 0. 3, 3 is cancelled. Okay. Next. So since we are getting 0 as the answer, therefore x is equal to minus 1 by 3 is the 0 of P of x. That means it is the 0 of this polynomial. Second one. Value of x he wants us to put as 4 upon 5. Let's put it. P of 4 upon 5, if you calculate P is equal to 5 into 4 upon 5 minus 5. 5 will cancel. 5 cancels. You have 4 minus 5. 4 minus 5 is not equal to 0. It has some numerical value. So since it is not 0, therefore x is equal to 4 upon 5 is not the 0 of the polynomial P of x. Third one. He wants you to calculate whether x is equal to 1 is a 0 or x is equal to minus 1 is a 0. So for two values of x we have to calculate. So let us calculate first for 1, P of 1. P of 1, so 1 square minus 1. 1 square is 1, 1 minus 1 is 0. We are getting, so P of 1 is getting at 0, that means 1 is, x is equal to 1 is a 0 of the polynomial. Therefore, x is equal to 1 is a 0 of the polynomial P of x. Now calculate for 2, so minus 1. So minus 1 raised to 2 minus 1. Minus 1 into minus 1 is 1. 1 minus 1 is 0. Again, for P of minus 1 also we are getting the value as 0. Therefore, x is equal to minus 1 is the 0 of the polynomial. Yeah. Take the fourth one. Here again we are going to calculate for two values, minus 1 and 2. So let's put minus 1 first. Minus 1 plus 1, minus 1 minus 2. Plus 1 minus 1 is 0. 0 into minus 3 is 0. So that means P of minus 1 we are getting 0. Therefore, x is equal to minus 1 is the 0 of the polynomial. Okay. So that means if the value of the polynomial is 0, then we say it is a 0 of the polynomial. Now let's take the next. P of 2. 2 plus 1 and 2 minus 2. 2 minus 2 is 0 and 2 plus 1 is 3. 3 into 0 is 0. So here x is equal to 2 is also the 0 of the polynomial. X is equal to 2 we get, it is a 0 of the polynomial. Clear? I think this is clear. Now we continuing with that same question. We're taking the next thing. Fifth bit, x square at x is equal to 0. When you put x is equal to 0, definitely it will be 0 only. Therefore, it is the x is equal to 0 is a 0 of the polynomial x square. Now, Lx plus m and x is equal to minus m upon L. Let's put the values. So if you see here, L will cancel. Therefore, you have minus 1, minus m and plus m, minus m plus m. Plus m minus m cancels and is again equal to 0 because plus minus is 0. Therefore, x is equal to minus m upon L is a 0 of P of x. Now, P of x, this is the problem. For two values, you have to calculate minus 1 by 3, root 3 and 2 upon root 3. Let's see. Minus 1 upon root 3 if you put. So, 3 into minus 1 upon root 3 whole square minus 1. So, minus 1 square, that means minus 1 into minus 1 is plus 1. Root 3 square is root 10. Square will cancel, it's only 3. Now, because it is both are numerators, so this will cancel. Here you got 1 and minus 1. 1 minus 1 is 0. So 1 minus 1 is 0. That means this particular value of x is 0 of the polynomial. Means x is equal to minus 1. 1 upon root 3 is a 0 of P of x. Now we do for second value. Here again, we get 3, 2 square, 2 2s are 4. And root 3 square is 3. Again, this will cancel. If this cancels, you got only 4 here, minus 1. 4 minus 1 is 3. We are getting a number here, it is not 0. Therefore, it is not the 0 of the polynomial. Clear? So this is what we are. 0 of the polynomial or value of the polynomial is one and the same thing. Only that if the value of the polynomial happens to be 0, it is called as the 0 of the polynomial. If it is not the 0, it is not the 0 of the polynomial. Okay. Now see the next one. 2x plus 1, you have to put x equal to 1 by 2. When you put x equal to 1 by 2, clearly you can see this should cancel. This cancel 1 plus 1, 2. You're getting a number here. So it is not the zero of the polynomial. Clear? Now find the zero of the polynomial in each of the following cases. Now see, this is a slightly different. The zero of the polynomial is that value of the variable for which p of x is 0. Now let us see. We have to find the zero of this polynomial. If p of x is 0, that means this here I must be getting 0 here. That means x plus 5 should be 0. P of x is 0, that means x plus 5 must be 0. If x is equal to 5, take plus x plus 5, take it on the side, become minus 5. Okay. So x is equal to minus 5 is the zero of this polynomial. That means that value of x, if you take, if it is going to become 0, that is called as the zero of the polynomial. Now see here, x minus 5. If x minus 5, then take minus 5 this side, become plus 5. So x is equal to 5 is the zero of the polynomial. 2x plus 5. 2x plus 5 must be 0 because p of x must be 0. So 2x plus 5 is 0. Take this 5 this side, it becomes minus 5. 2x equal minus 5. This 2 you bring it down, it becomes minus 5 by 2. So this is the 0 of the p of x. Okay. Next, p of x is 3x minus 2. So if this is 0, then 3x must be equal to 2 and x must be equal to 2 by 3. So this is the zero of the polynomial. That means if I substitute 2 upon 3 in this polynomial, the answer will be 0. That is the meaning. Next, 3x. 3x has to be 0. Then you bring this 3 down, it will come 0 upon 3. 0 upon 3 is 0. So that means x has to be 0 for p of x to be 0. X, ax. That means a is not 0. So that condition is given. So if it is ax is 0, then a upon x, 0 upon a must be 0. 0 upon a is 0 only. That means if x is 0, then p of x will be 0. What will be the value of x? X should be 0. Cx plus d. C is not 0, d is also not 0. They are some numbers. Okay. Now, Cx plus d. Take d this side. Cx is equal to minus d. X is equal to minus d upon c. Minus d upon c will be the zero of this polynomial. Yeah. Now, practice exercise 2.11. If you have watched my previous video, that is a solved exercise of 2.1, I had given a practice exercise. I'm solving it here so that you can check whether what you have done is right or wrong. Now, which of the following expressions are polynomials in one variable and which are not? So now let us see the first one. Polynomial in one variable. Here I am having x also is a variable, y is also a variable. How can I say it's a polynomial in one variable? Here the variable used are two, that is x and y. So however, the power of the variable is a whole number. It is a polynomial, but it is not a polynomial in one variable. Therefore, it is a polynomial in two variables. Now, t is used. T is used. Variable used is only one. But this is inside the root sign. So that means the power of this variable is a fraction. So here the variable used is t and the power of the variable is a fraction. If the power of the variable is a fraction, then it cannot be a polynomial. Here again, variable is t. Power is a fraction. So it is not a polynomial. Here, variable is x. Only one variable is used. Powers are all positive, whole numbers. So here the variable used is x and the power of the variable is a whole number. Therefore, it is a polynomial in one variable. Okay? Now see here. 1 upon x. This x is in the denominator. If I were to write this in the numerator, I'll have to write it as -1. That means here the power of the variable is negative. Variable used is 1. Power of the variable is negative. Therefore, it is not a polynomial. Yeah. So this was the first question I have solved. Now take the second question. Coefficient of x raised to 3 in each of the following. Coefficient means what? It is the number in front of x raised to 3. Number in front of x raised to 3 is the coefficient of x raised to 3. Okay. So here x raised to 3 is here. The number in front of is 2. So therefore, the number in front of x raised to 3 is 2. So the coefficient of x raised to 3 is 2. Second one. X is asked to x raised to 3. So in front of x raised to 3 is 27. We are not bothered about y. So we just write number in front of x raised to 3 is 27. So the coefficient of x raised to 3 is 27. Next, x raised to 3 is here. Number in front of it is 4. So the number in front of x raised to 3 is 4. Coefficient of x raised to 3 is 4. Next, x raised to 3 here. So root in front of it is this. Therefore, coefficient number in front of x raised to 3 is root 2. So the coefficient of x raised to 3 is 2. Yeah. Fifth one. X raised to 3. Clear. So now you can see here. So the coefficient of x raised to 3 is 2 by 5. Next. X raised to 3. Number in front of it is 4. Coefficient is 4. Clear. So coefficient is nothing but the number in front of the particular variable it is asked. Give one example each of a binomial of degree 28 and a monomial of degree 75. Binomial means having two terms and the power of the variable in that expression must be 28. So see the solution. Binomial of degree 28 is y raised to 28 plus 3. This is one term, this is second term. It's got two terms. So it is a binomial in of degree 28. You can take the second example. 5x raised to 28 plus 6. It's also a binomial because having two terms. Therefore, and the power of the variable is 28. Therefore, it's a binomial of degree 28. Now let's take a monomial. Means having only one term. So y raised to 75. One term and it's a polynomial having degree 75. 125 x raised to 75. It's a polynomial of degree 75. Find the degree of each of the following. Degree is what? Highest power of the variable in the particular given expression. So see, this one, what is the highest power here? Here 1, 15, 30. So highest power is 30, so degree is 30. Highest power of x is 30, so degree is 30. Here highest power is 3. So highest power of the variable is 3, so degree is 3. Though it has got two different variables, the highest power only has to be seen. Next, highest power is 125. So degree is 125. Next, u is a variable. No power is means power is 1. Degree is 1. Highest power of the variable u is 1, so degree is 1. There is no power of, no variable is there. It's a constant or number. 25 can be written as 25 x raised to 0. X raised to 0 is 1. That means this doesn't affect 25. So power of the variable is 0. So the degree is 0. So degree of any real number is always 0. You can take any real number. Degree will always be 0. Classify the following as linear, quadratic and cubic. Linear polynomial means if the degree is 1, it's a linear polynomial. If degree is 2, it's a quadratic. And degree is 3 is a cubic polynomial. So let's solve it. Here, the power of the variable x is 1. Therefore, it's a degree is 1. So it's a linear polynomial. Second one, degree is 3. Highest power is 3. So it's a cubic polynomial. Third one, highest power is 3. So it's a cubic polynomial. Fourth one, highest power of the variable is 1. Degree is 1. So it's a linear polynomial. Next, highest power is 2. Degree is 2. Therefore, it's a quadratic polynomial. Here, 12p, power of the variable is 1. It's a linear polynomial. Now, x plus 2, x minus 5. So this if you multiply, okay, it will become x squared minus 3x minus 10. So here the power becomes 2. So degree is 2. It's a quadratic polynomial. If it is given in this way, you will have to multiply it. You just can't just look at this variable and say 1 is a power, therefore degree is 1. No, you'll have to multiply it. And after multiplying the highest power which you get, you will decide the degree and then write what is the nature of, or what is the type of the polynomial. Now this is for your second now exercise which you have just studied, finished. Exercise 2.22. These are the practice questions. Please do this and watch my next video for the solution of this. Okay. Hope I liked it. So please don't forget to subscribe for it and press the icon.